Hi, everybody. VMworld 2021 is over, but we thought it would be a very good time to give you a last present for this year. So we are going to present you the updated version of the NSX-T and infrastructure as code. My name is Nicolas Michel, and I'm a technical product manager in the networking and advanced security business group. And I am thrilled to present you this session. We got a lot of feedback from VMworld. I received plenty of emails, Slack messages, the tweets, and it was a pleasure to present that session. Coming from a networking background and be able to present infrastructure as code, well, in the context of NSX-T, that really helped on your day-to-day basis, how your workflow and how you deploy and interact with the NSX-T platform. So let's get going. Usual disclaimer that you may see in a lot of VMworld presentation. All right. So I'm going to jump right into the topic. So we have a new version of NSX-T that is coming in the next few weeks, and I wanted to take the opportunity to talk about infrastructure as code as well, and introduce you to the world of automation. Right. So before talking about automation and infrastructure as code, you need to really make a plan on what do you need in order to deploy your NSX-T environment, right? What do you need from zero to network connectivity and to having your workload in your NSX-T domain? What do you need for that? Well, if you had to do it manually, this is what you see on the screen. This is what you really need. First, you will need to deploy your NSX-T manager, right? That's a manual process. You will need to upload the OVA to your vCenter environment, and then with all the parameters, IP address, host name, etc., etc., etc. Then, as soon as the NSX-T manager is deployed, right, you will need to do all the basic configuration. And what do I mean by basic configuration? Well, first you will need to install your license. Then you will need to register your vCenter to your NSX-T manager. Then you will need to create your uplink profiles, your IP pools for your tabs for all your overlay workload, right? Then as soon as you have that, you will need to think about your networking construct, your tier 0. How many tier 0 do you want? How many tier 1s? Do you want multi-tier or single-tier routing? What kind of routing protocol do you want to implement in your networking fabric? Do you use BGP? Do you use OSPF? You need to think about that. In terms of the convergence, do you rely on BFD? Do you have some IPv6 workloads? That's all the question that you need to ask beforehand, and then you will need to provide some virtual machine in order to test your connectivity, etc., etc. What I do on a daily basis at VMware is that I'm in charge of the layer 3 features and of the edge platform. So whenever we come with a new feature, I need to test it, and I need to test it on a particular version. So what I need to bring down my entire lab, and I need to redeploy my entire lab with a new version, right? In order to do that, I leverage infrastructure as code, because if I had to do that manually, it would take me hours just to deploy my NSX-T managers and to create all my basic configuration. So that's why I came with the idea of automating all my topologies and all my basic deployment for NSX-T. Because if I had to do that manually, it would take me so much time. Well, I'm pretty sure I would do a lot of errors, a lot of typos. So I took the opportunity and the time to really leverage infrastructure as code, so that I can test any topology with any version of NSX-T at any time. So basically, that's why I'm leveraging infrastructure as code, and that I recommend you to do the same thing. You will get a lot of your time back. You will see that if you have to deploy multiple versions of NSX, if you have to deploy your test environment, your staging environment, your production environment, that's really important, that you can replicate and test your code before going to production, for example, and then replicate that code when you want to go live, right? So that's why I came with the slide. So it's really important to understand at which point do you want to leverage infrastructure as code. If you have one task that you will have to do just once, do you want to take the time and to really invest a lot of time by developing some code just for that one task? Maybe not. But if you have multiple tasks, if you have one task that you will have to do a lot of time, well, maybe it is a time to consider infrastructure as code. And if you are working in a team by collaborating with all the tools that we have that are available as of today, like Git, etc., it's really important to make sure that you are productive, right? It's really useful, especially for professional services, where, for example, you will install an NSX-T manager, and then another day you will have another project, but you will still have your baseline of your code where you will be able to reuse that code for another project. So that's really, really, really useful. So infrastructure as code, what does that mean, and how do we do it, right? It's something that's been in the industry for quite a long time now, and there are plenty of tools that are available. And the reason that there are so many tools is that there is not one single tool that is available and that is the best tool for everything. Every tool are very specialized, if I could say, and maybe Ansible is the best tool for something, and the Terraform is the best tool for something else. And that's why I'm going to use multiple tools in this environment, in these demos. But just wanted to show you how NSX-T is flexible, right? NSX-T is really the center of this presentation as of today. So you will see how can we use multiple tools and leverage infrastructure as code using these multiple tools. So first, as I mentioned previously, you will need to deploy NSX-T and do the basic configuration. And in order to do that, I tend to prefer to use Ansible. Ansible is very robust and is very used if you want to deploy your virtual machine, etc. So that's what we are going to see. We're going to use Ansible to deploy our basic infrastructure. Then we are going to use the Terraform and native REST API in order to deploy all your networking construct, right? If you want to deploy your BGP topology, etc., it's in my opinion, the Terraform is the best tool for that. We also are going to use REST API, and I will show you how to use REST API in the best way in this presentation. And as you can see, all these tools like Ansible and the Terraform Cloud rely on REST API, right? They interact with NSX-T APIs because REST APIs is really a center of automation with NSX. We'll talk about that a little bit later. Then at the end, when all your networking construct will be deployed, you will need to test with some virtual machines so that you can test your network connectivity, etc., and your performance. So with that, I'm using the Packer and the Terraform. So with Packer, you are able to create a template, and the Terraform will leverage that template a little bit later in order to deploy all your virtual machines for your workload. So REST API. So it's really important to understand that API is the center of NSX. When engineering, when we at VMware, when we introduce a new feature, we think API first. Basically, the UI comes way later, but really, when we design a feature, we really think about designing the API in a very simple way, so that you can achieve everything that you can with automation. Then the UI comes next, and the UI will be only used it will be an API consuming tool if you want. So, and we introduced Policy API in a previous version of NSX, where with one API call you are able to configure one object, but and all its other the child objects. So, for example, if you want to configure one tier 0 with a single API call. You can create one tier 0 with all its interfaces, the BGP configuration, etc. So that will simplify a lot of things. Speaking of API, how do we know about these APIs? So, for example, so you have two ways. The first way would be to check in the documentation. So you have the link right here. And the other way would be to perform some tests in the UI. So that's how I do something. When I do it sometimes. So in this particular example, I'm creating a segment. So I provide a name. It's not connected to a tier 0, for example, and the transport zone is the NSX overlay transport zone, and I put a subnet, right? Then if you check on the web developers tools on your browser, you will be able to check the particular API code that we make to the NSX-T manager, and then you can replicate that in Postman or in Python so that you can create everything you want. So infrastructure as code, the way I do it is that I took infrastructure as code to the next level. I do infrastructure as code as well on my container. So I created a container that will have all the tools I need in order to perform my day-to-day activities from a DevOps standpoint. So you can see here on this particular slide, I have my vPacket container that has the Terraform, Ansible, it has Python, it has Vault, it has everything I need. If I want to change a version, if I want to install a new tool or change a version, I just have to kill my container, change the version in the code, or just to add another line of code in my Docker file and rebuild that container. Then I just have to launch that container, and I will be able to reuse it the same way as before, and I will be able to do versioning of my container, etc. If I want to roll back, etc., and have all my tool on a single container. If I'm working on another laptop, another computer, my container is still there. So it's really, really useful in my opinion. So I've been doing that for approximately 3 or 4 years now. So you can have the Docker container right here if you are interested. And all the code that you will see today is already in GitHub. In the SDDC demos repo that you will have, that you can see here. And do not hesitate to send me a tweet or an email or to interact with me in any way, to ask me a question about that repo. So you have multiple ways to use infrastructure as code, because you will have to, maybe if you use my repo, for example, you will see that there are plenty of variables that are my variables for my lab, etc. But you will need to make sure that these variables will need to be changed in order to match your environment, right? You have multiple ways to do that. Either you change the variables in the answer file, or what you can do is to create a vault, right? And put all your variables and protect all your sensitive data into that vault, right? That's the best way if you want to leverage infrastructure as code in your production environment or even in your lab. So deploying an NSX-T infrastructure with Ansible. I'll show you how to do that. So Ansible, that's a pretty well-known tool in the DevOps industry and in the networking industry. So I will be very fast on this slide. You can see here we have our playbook, and you will see that we are going to use the NSX-T deploy OVA module that has been the provision, and has been the provision by VMware, and you will see all the variables that this module needs in order to deploy the NSX-T manager on the vCenter. You will need to know which data center, which data store, the port group, the IPs, the DNS, etc., etc. So put all your variables either on the answer file or on Vault in order to deploy your NSX-T OVA. So my first playbook will be, in fact, a collection of playbooks. I will deploy my NSX-T managers, and then I will I will have another playbook in order to register my vCenter to NSX-T. I will also need a playbook in order to apply my license, etc., etc. And I do love the idea to have multiple playbooks, because if I want to change the task, if I want to change something in the playbook, that will not affect the entire workflow, right? And I like to segment things a little bit. Then I will need to create my uplink profile so that I can leverage single tap or multi-tap and have my deterministic BGP traffic. I will also create my IP pools for my the compute and for my edge nodes, etc., etc. So we'll see that. Also, we'll enable IPv6. So you will see that we are able to provision an IPv4 and IPv6 domain with automation. I will create 2 edge cluster profile, one for the bare metal edge and one for the VM edge, because the timers are different from BFD standpoints. So I would like to have these 2 edge clusters available already in every infrastructure that I work with, so that if I want to implement a bare metal edge, then I have my edge cluster that is already up and running. I just have to install it. And then I will also use Ansible to deploy my NSX-T edges. So let's get going. So that's my shell script that will have all my playbooks and all my playbooks. So you can see here I'm deploying my OVA. So my OVA has been pushed to my vCenter environment, and then it will register my NSX-T, my vCenter to my NSX-T manager. And for that, I'm doing REST API, as you can see here. Then as soon as we have that, we'll apply the license to the NSX-T manager, because we want to deploy edges. So you will need a license, right, for that. In the meantime, I'll check if we have some questions. Then yes, we need to create the uplink profile, the multi-tap, and the name teaming policy for BGP. So you can see Ansible will be used in my particular case to deploy the basic infrastructure that I will not need to touch after that. I won't need another edge profile. I won't need to have another transport zone. I already have it handy in Ansible, and I configure that very quickly in Ansible. And then I will leverage Terraform in order to create all my networking construct with my tier 0. And my tier 0 will reuse, my tier 0, my tier 1s, my overlay segments will reuse all the objects that I created using Ansible previously. So here we are enabling IPv6 and setting the MTU to 9000 using REST API. So you can see that we have a 200. So it's good to go. And I'm creating my edge clusters for my VM, for my edge VM form factor, with the BFD timers of 500 milliseconds for the best the convergence time. Same thing for the edge bare metal cluster with a BFD timer of 50 milliseconds, so that I can again leverage the best convergence time. And then I deploy. So I'm redeploying I'm reusing another module in order to deploy all my edge nodes, right? And with that particular playbook, I was able to install NSX on all my hypervisors and deploy my my NSX-T edges. So if I look at the UI, I don't have any networking objects, right? Because I haven't deployed any tier 0 or something. I have my IP pools that I talked about previously. I have IPv6 and IPv4 enabled with the MTU of 9000. So I'm good to go from that standpoint. I will be using Jumbo MTU, Jumbo frames right here. And we don't have any network entities. If we go to the fabric and you can see the node, we can, here in this lab, I have only one ESXi, but if you had hundreds of ESXi in your clusters, NSX-T would have been installed without any click to these 100 hypervisors. I have my 2 edge clusters, as I mentioned previously, and these 2 edge clusters, that's my edge cluster profile, that's my transport node profile, and we should be good to go. We should be good to go and be able to deploy all your networking construct and be ready to play with networking objects. yeah, so the vCenter is registered, up and running, and we are good to go. So now that you have deployed your entire NSX-T infrastructure, now it's the time to deploy your NSX-T networking objects, load balancing, firewalls, etc., etc. So I will not touch Ansible anymore for this particular for the following demos because Ansible was done and was used in order to deploy all my NSX-T basic infrastructure. So that's the topology that we are going to work on today. So in green, you can see that we have two tier 0 that are spread on multiple edge nodes. So we have the first tier 0 that will be hosted on edge node 1 and 2. That tier 0 will be in active standby mode. And I have another tier 0 on edge node 3 and 4 but this particular tier 0 will be active. Each tier 0 will leverage multi-tier routing. So we'll have two tier 1s attached to each of the tier 0, and each tier 1s will have 3 segments. One segment for the app servers, one segment for the web servers, and one segment for the DB servers. And the interconnection between the tier 1 and tier 0 is automatically done in NSX-T, but also with infrastructure as code, I will be able to really attach the tier 1s directly to the tier 0 and redistribute all the routes directly. So I'll be doing that with Terraform. You can see here, in order to have Terraform, so you will have to install Terraform on your container, on your virtual machine, on your laptop, etc., etc. But then, when you are working with the Git repo, you will need to install the provider, right? So the provider is managed is developed by a lot of developers, and a lot of them are at VMware. And then once you have the NSX-T provider installed, you will be able to leverage and create resources. So you can see in this example, we have one resources for one logical switch, and we have all the variables that are mentioned here. So if you are alone and working in your lab, how does it work? You are connected to you are using Terraform, and your intent is to push a configuration to the NSX-T manager. Well, Terraform will do that. It will check the intent of your configuration and push that configuration to the NSX-T manager, which in return will realize the state of your intent. Then the state of your configuration will be written in a TF state file, but that TF state file will be hosted locally on your computer, or on your virtual machine, on your container. And that TF state file will be in clear text, right? So you will see all the variables that are used. These variables that are used in order to replicate that state. And in the next time that you want to do a change, it will check the current state of your NSX-T environment, and it will check into that file. So you can see the problem here, so that your production environment, if you are in that particular case, would have all your variables, all the state would be configured in a single file with no versioning, no encryption, etc. So that might be a problem. But if you are in a team of engineers, it would be better to use the Terraform Cloud, so that the state of your NSX-T configuration is encrypted and is in the cloud. So you can see here how to leverage that, and all the pros for all your Terraform Cloud. So let's get going with the Terraform demos. So in this particular case, I will really focus on the networking construct in order to keep all topology very simple. I'm not configuring any load balancers and etc., but I will really focus on networking. I will create some VLAN segments, overlay segments, all my tier 0. I will have to mention and configure all my external uplink interfaces, loopbacks as well, your entire BGP, so that after you apply your Terraform configuration, you'll be able to directly see your BGP peering, the relationship that is established between your top of racks and your NSX-T IaC. So really useful. That's an example of the code. We see here that we have VLAN segments IaC, and we are enabling redistribution already. So you won't have to do anything. Basically, you specify everything that you want in your code. You specify your intent, and then the Terraform will push that intent to the NSX-T manager, which will realize the state of your intent. Same thing for the IaC. So here I specify my IPv4 and IPv6 address. My BGP neighbors, where if I want BGP or not, my BGP password, and the address family, so that I don't have to go into the UI and then change the address family afterwards. I can just change it in my code, add, for example, the L2VPN EVPN address family, so that I can exchange EVPN route type 5 prefixes with the physical fabric in this particular case. My tier 1s will also be mentioned, my overlay segments as well. And then, yes, again, IPv4 and IPv6 at the same time, so that I can provision my dual stack infrastructure pretty quickly. Let's get going. So I'm going a Terraform plan. The Terraform plan will check the intent of my configuration and will try to understand what is the delta between my intent and what's configured actually in the NSX-T platform. So you can see here we have 55 objects to add, 0 to change, 0 to destroy. So we have to configure basically everything. If I do a Terraform apply, then it will do the same operation and it will ask me to confirm, and then it will deploy everything. And yes, it's pretty quick. You can see that multiple objects are created pretty quickly. Creation completed after 1 second, 2 seconds. So all my objects have been created. I've been pushed to the NSX-T. Now it will take a little bit of time for NSX-T to create all the objects, because you have some child objects. Obviously, you cannot create the interface of your IaC before creating the IaC itself, right? So you will have to give it a little bit of time, but it's really, really quick and it's really well done. You can see here, I already have my IaC configured. My network topology is already created. I have my IaC with my uplink interfaces. My connectivity between my tier 1 and my IaC is already done. I can check my BGP neighbors. My BGP neighbors are configured, and you can see I have green lights everywhere, both on the IPv4 and IPv6 neighbors. So now if I log into my Edge platform, I just want to show you, if I go to VRF15, which is my IaC SRs, and if I do a get BGP, I should be able to see the routes that are exchanged, right? So get BGP neighbor summary. I can see that I have IPv4 and IPv6 BGP peering established, and I'm exchanging some prefixes. My L2VPN EVPN family is negotiated, but I'm not exchanging some prefix at the moment because I didn't want to. And that's my BGP table. So you can see I'm exchanging traffic. Well, I'm exchanging prefixes with my top of racks, and these routes are installed now in the IPv4 and IPv6 routing tables. So without any clicks, as of now, we were able to install NSX, deploy our NSX-T edge nodes, deploy the NSX-T VIBs on all the hypervisors, do the basic configuration. Then, without another single click, we were able to create all the networking construct and exchange and establish BGP peering connectivity with the top of racks and exchange routes. Right. So now that we have the routes, we have control plane that is up and running. Data plane is okay. We'll check if we have some if we can have some traffic exchange between the NSX-T fabric and the physical networking fabric. In order to do that, I will use Terraform and Packer. So I will use Packer first in order to create my VM template. So my VM template is based on the Ubuntu 18.04, And using that Packer template, I'm able to specify the amount of memory, the amount of disks, the amount of CPU that I need for these VMs. And then the Packer will create that template, and then it will shut down that template, and Terraform will leverage that template in order to deploy all the virtual machine. I will just have to change some parameters if I want to, like the host name, the IPv4 address, obviously, because they will be on different subnets, and the segments in NSX-T. So the segments have been the NSX-T segment have been provisioned in the in Terraform a little bit earlier. So now I will tell Terraform to reuse these segments and to attach the NICs of the virtual machines for this particular segment that have been created. So with Packer, you can see I'm downloading the ISO. Well, Packer is downloading the ISO that I specified in my code, re-uploading the ISO to vCenter, and then creating one VM. And then it will transform that VM into a template. So that's what it's doing at the moment. It's installing it. It's installing the VM automatically. So it's installing the VM automatically. The only requirement here is that you have DHCP that is enabled on a particular VLAN to create the VM, so that it can install all the software that you want, do all the updates, etc., etc. So once Packer is done, it will shut down the template, convert that template into it will shut down the VM, and it will convert that VM into a template, a VM template, and then the Terraform, as I've explained here on this particular slide, I'm using Terraform in order to reuse that template to deploy my virtual machine. So the code is very, very similar here, and I'm just changing the host name, the network mask, obviously, the IPs. What else? Yep, you name it. So now I'm doing exactly the same as I've done previously with NSX-T. I'm doing a Terraform plan to check my intent and to check the delta between my intent and my virtual machine that are installed in vCenter. And I'm planning to add 8 virtual machines in this particular case. And I'm cloning, if you want, the template. I'm reusing that template to deploy this virtual machine. And if you can see, I just did a ping. So that ping was from a virtual machine that was outside of NSX. So now I can witness that I have IPv4 connectivity between my VM that is outside of NSX towards my VM that I just created. I have connectivity from an IPv4 and IPv6 standpoint. And again, no interaction from me. Everything has been done automatically. So let's check into NSX the number of virtual machines. Yes, you can see NSX sees these virtual machines that I've created in vCenter. You can see the IP. You can see the IPv4, IPv6, the VIF, on which port it is, what it is attached, etc., etc. After that, the beauty of infrastructure as code is that if you want to change something, if you want to reuse your infrastructure for something else, I can just destroy my virtual machine or my tier 0, etc. That's what I'm doing daily. If, for example, I want to test a load balancing architecture, or if I want to use something like OSPF or EVPN, I can just destroy and reuse that code for something else. That was up from, well, that's all I had from a demo standpoint. I will see if I can have some nice questions right here in the comments. Let me see. Yeah, we got some question about CI/CD. config management with restrictions. Yes, definitely. You can use your usual CI/CD pipelines in order to do that. Do you guys have any other question on what you saw? What's also available, I will show you. You go back to the code. Yeah, so everything that you saw here today is available on github.com/vmware-nsx/sddc-demos. The repo is already up. So you will have only one topology here, the topology that I presented, but I have many topologies. I have OSPF topologies. I have EVPN if you want. So I will be able to upload these particular topologies really soon. All right. Thank you very much, everybody. I hope this was informative for you. Do not hesitate to reach me on Twitter, by email, if you have any question about the capabilities of NSX-T from a networking standpoint, but also from an automation standpoint. I would be glad to answer your question, and if I can't, I will redirect you to the right person. So, okay, we got one more question. Have you looked at handling prefix lists and route map in NSX-T? It appears that the way prefix lists and route map have been architected in NSX-T is that they seem to be neighbor specific. Yes, that is right. When you create a route map, when you create a prefix list, you usually assign that prefix list to a route map, and then you reuse that route map on a particular neighbor. That's basically what has been done in the networking industry from BGP standpoint. If I'm taking that example, I'm not talking about other example, but if I'm talking about filtering in BGP, which is a very common use cases, you usually use your prefix list, and then you apply that prefix list to the route map, and you apply that route map to your neighbors. But you can reuse these route maps to all of your neighbors, or just to one. It depends on the number of peering that you have. Terraform is more geared for when your infrastructure is deployed. Yes, that is correct. That is a very that's a very valid statement. Yes. Day 2 Terraform makes more sense. Exactly. Ansible is definitely better for day 1, for day 0, and day 2. You can definitely use the Terraform in order to leverage your entire production environment. Yes, I would definitely use Ansible on day 0. Yep. I can definitely send something in the chat. So let me see if I can. I only have access to the comments. I cannot post in the chat. So if can somebody paste that into the chat, that would be very useful. Do we have a blog which talks about NSX-T and Terraform? I believe it's Terraform. So we have some blog posts at VMware. So if you look at the official VMware blog post, I'm pretty sure you will find something about the Terraform. I'm pretty sure. Perfect. You already have the code over there. Well, with that being said, if we don't have any more questions, it was a pleasure to present this session about NSX-T and infrastructure as code. Well, again, do not hesitate to reach out if you have any question related to networking in NSX-T. It will be a pleasure for me to answer your question, and we promise that will generate more the content on these particular topics. All right. Thank you very much, guys.